This will be for the con exercise. Graph sinusoidal functions, phase shift. Now there is an exercise, graph sinusoidal functions without the phase shift. Okay, I suggest you do that one first. All right, so you want to be familiar with the graph of y equals sine of x. That's this one here in red. And of course, y equals negative sine of x is the same as sine of x, but it is reflected over the x-axis. So the one in blue right here is y equals negative sine of x. Also, you need to be familiar with y equals cosine of x. So that is this graph here in red. And y equals negative cosine of x is the same as cosine of x, but it is reflected over the x-axis. So this one here in blue is y equals negative cosine of x. Okay, so you need to know those as well for this exercise. All right, so here we have the basic sine equations. And the thing is, when you have x without a coefficient in front, inside the parentheses, that is in factored form. Okay, if you took this k and distributed it, it would look like this, and that would be unfactored form. All right, so really, these are the same equations, just written in different forms. But either this or this right here is the basic sine or cosine equation. You can replace sine with cosine. All right, so I use slightly different lettering than they use on Khan Academy. But at any rate, A is the coefficient out front. The absolute value of A is the amplitude. B is the phase shift. Okay, and really, you can't really see the phase shift when it's in this form. It needs to be in factored form, okay, in order to see the phase shift. Okay, 2 pi divided by k is the period, and k is always the number that's times x. It is the coefficient on the x. Again, it's usually a little easier to see when it's in factored form, but even when it's unfactored, k is the coefficient times x. And finally, c is the midline. Okay, so plus or minus c is going to be your midline, and that is the same whether it is factored or not. Okay, so we are using all of these on this exercise. All right, so it says g is a trig function of the form, and it's in this form here. Again, I use different letters, but this right here is clearly unfactored. Okay, and how do I know that? Because x has a coefficient in front of it. Okay, you can see x is multiplied by b, so that is not factored. I believe the answer has to be in this form. Okay, if not, then I'm going to factor it, and I'm going to try to enter that answer in the box, but I believe it has to be in this form. Now, they gave us the maximum and the minimum in the write-up, but it is on the graph. Okay, and they want us to write the formula, really the equation, and it probably has to be in this form. Okay, I'm going to try to factor it and put that form in, but at any rate, we're looking to get the equation of the graph. All right, so this is the graph right here. All right, so let's see. If I were to highlight the graph, I kind of want to start at the y-axis, but I can't always do that because there's a phase shift. But if I were to highlight from here and just do one period going here and then here, that is clearly a negative cosine. Okay, remember we said we wanted to start with sine or cosine, or negative sine or negative cosine. This is clearly a negative cosine. All right, so I'm looking to write the equation in this form. This is factored form. Like I said, if they don't take it, I will just unfactor it. Okay, I'll just distribute it, multiply it through. Anyhow, let us start with the amplitude. Okay, that's going to be the absolute value of A. We have a minimum and a maximum. Okay, so the amplitude is going to be the maximum minus the minimum divided by 2. Okay, because the amplitude is basically half the height. All right, so if you went in the middle right here of this graph, the amplitude would be that vertical distance right there. All right, so we're looking at y coordinates. The maximum is at -4. So in place of max, I'm going to put -4 minus, and the minimum, we can see that is at -5. Okay, so it's minus -5, and that is divided by 2. Two negatives make it positive. -4 plus 5 equals 1, and that is divided by 2. So it's 1/2, or you can write 0.5. All right, so that's the absolute value of A. So in place of A, I'm going to write 0.5. But we said previously when we highlighted the graph, it was a negative cosine. All right, so we're starting with negative cosine, and we just put in the amplitude A. Now let's find the period. Okay, we know the period is maximum to maximum or minimum to minimum. It is basically the horizontal distance. All right, so this right here would be a period. So if we only went to this point right here, that horizontal distance would only be 1/2 of the period. All right, so if we just find this distance here, we can just do times 2. All right, because this is only half the period. So it's going to be times 2. And now since we're doing horizontal distance, we're looking at the x's. Okay, really you just subtract and take the absolute value, or you can put the larger number first. All right, so it's going to be 2 times, and this is a 3.5 minus -1. And take the absolute value. Okay, so that's going to be 2. 2 negatives make it positive. 3.5 plus 1 is 4.5. Okay, and 2 times 4.5 is just 9. Okay, remember this is a distance, so it's always positive. Now remember the formula for the period is 2 pi over k. All right, and that equals 9. That's our period. So if you cross multiply, 9 times k equals 2 pi. All right, you want to cross multiply. 9 times k equals 2 pi, and the opposite of times 9 is divided by 9. All right, so k is going to equal 2 pi divided by 9. All right, 2 pi divided by 9, that goes in place of k. Parentheses, we have an x, and let's do our phase shift. So normally, we would want to start right here on the y-axis, but we can see this is shifted. This right here is shifted to the left. All right, how far is this graph shifted to the left? Well, the x-coordinate is -1. All right, so clearly it is going left. Left by 1 unit. Okay. Remember, when it goes left 1, you want to do +1 to the x. You want to add 1 to x. All right, because shifting left-right is opposite. When you go left, it's positive. Right, it's negative. So to go left 1, you have to add 1 to x. So here's your x, and it's going to be x plus 1. All right, so that was for the phase shift. Finally, what I hope is the last step is the midline. Okay, remember the midline runs right through the middle of the graph. All right, so the midline is your C. All right, midline, but we know it's C. And that is going to be the average of the y coordinates. All right, because it's right in the middle. So it's going to be -4 plus -5. All right, -4 plus -5. And that is divided by 2. All right, and let's see. -4 plus -5 is -9 divided by 2. And it's easier to enter it as a decimal. So -4.5 is going to be your midline. And that's your value for C. -4.5. All right. Try not to get amplitude and midline confused. This right here is the midline, and you just want to write the equation of that line. That's y equals -4.5. Okay, because this line is a horizontal line, but it goes right here on the equation. All right, so I'm going to try to enter it in this form. I don't think it's going to take it. Okay, but I'm going to start with -0.5. I'm going to type cosine. Okay, and I'm going to use the parentheses twice. So I'm going to do 2 pi over 9, 2 pi/9, and use parentheses again, x plus 1. Close the parentheses twice, and then do minus 4.5. Okay, so I wrote it in factored form. I don't think it's going to take it, but let's just see what happens. Oh, great, terrific. Okay, fantastic. So you can write this equation in the factored form. It's actually much easier that way. All right, so there you go. It took my answer. It took my answer exactly as it was. All right, so briefly, I just want to show you on this problem here, they say the equation is in the form of a times sine, okay? But that does not mean you have to use sine. All right, if you look at the graph that they gave us, whoops. If you look at the graph they gave us, you want to try and start at the y-axis here. And if I were to highlight this part of the graph right here, one cycle, all right, if I went from there to there, this right here is just a graph of a cosine, okay? And it has no phase shift because the maximum starts right here at the y-axis. So even though it said it's in the form of sine, you can use cosine if you want, and there's no phase shift. It's actually easier that way. All right, so if you want to pause and try this one for a moment, I get 4 cosine of 2x plus 3. All right, and it still accepted it. All right, so on this one here, we have this equation, and they want us to graph it. You basically need to factor this, okay, because you can see there's a coefficient on x. We need to factor this 100%. And then break it down. So really, the only thing you need to factor is the coefficient on x, all right? So f of x, that's the same as y equals, we have 5 times the sine, and you want to factor out the coefficient on x. So it's going to be a 2 parentheses x, all right? You can see it's 2 times x. And now you want to do the -3 pi divided by 2. All right, if we did -3 pi divided by 2, well, that's just going to be -3 pi over 2. All right, so that is going to go right here. -3 pi over 2, close parentheses. If you want to see if you did it correct, just distribute. 2 times x is 2x. 2 times -3 pi over 2, the 2's would cancel, and you would be left with -3 pi. We still have a -2 on the end. All right, so that is going to be the factored form. All right, so that is in this form, and now we can break this down. Okay, we can see that the amplitude is just 5. So A equals 5. All right, if you want to make it the absolute value of A, that's your amplitude. And let's see, the period. That's going to be 2 pi over K. And what do we have for K? Let me fix that. What do we have for K? Well, we can see that K is 2. All right, because we put it in factored form. It makes it so much easier. 2 pi divided by 2, the 2's cancel, and that just equals pi. All right, so that's your period. And the phase shift. All right, the phase shift. We see that we have a negative 3 pi over 2. All right, negative 3 pi over 2. And what does that mean? When it's negative, it shifts right. Remember, for the phase shift, it's reversed. When it's negative, it shifts right. So this means it's going to go right by 3 pi over 2. All right, that's your phase shift. And finally, the midline is just C. And C equals negative 2. All right, that means the middle of the graph is at y equals negative 2. All right, so we have to use these characteristics, including the basic sine function, to plot this graph. All right, I'm going to start with the basic sine function, and there's no negative sign out front, so it's not going to be flipped. It's just going to be the basic sine function. So remember, this point here always has to be at the midline, and the other point is either going to be a maximum or a minimum. All right, so we can see already we kind of started with the basic sine function. It starts at the midline, it goes up to the max, and then down to the mid. All right, so we do have the sine function. The amplitude is 5. Okay, usually the sine function maxes out at 1, and the minimum is at negative 1. This is going to be multiplied by 5. So this is at y equals 0. 0 times 5 is still 0. But this, instead of being at 1, it's going to climb all the way up to 5. All right, and when you move the maximum point, it fixes the minimum point as well. All right, so we got that out of the way. Now the period is going to be pi. But here's the problem now. From this point to this point right here, this distance, that's only 1/4 of the period. Okay, so if I did 1/4 of the period, that's going to be 1/4 times pi. It's just 1/4 pi. All right, so this distance right here should only be 1/4 pi. Or you can say pi over 4, same thing. All right, so let's fix that real quick. All right, so we're only moving left, right. So if I moved it to here, from here to here is still pi. All right, we want it at 1/4 pi. If we move it here, that's half of pi. All right, because this is pi, this would be half of pi. So we still need to move it right there, okay? That is only going to be 1/4 pi right there. Okay, next up is the phase shift. And the phase shift, we said it has to go right by 3 pi over 2. All right, every two blocks in this is pi. So 3 pi over 2 is going to be 3 blocks. Or it's going to be the same as 3/2 pi. All right, it has to go right by 3/2 pi. This is pi, this is 2 pi. So 3/2 pi is going to be right in between. So let's see. That is going to be 3 blocks. So I'm going to take this. It's at half right now. All right, now it's at 1.5, 2.5, and 3.5. All right, see, 1, 2, 3.5. Same thing here. I have to move it 3 blocks to the right. So 1, 2, and 3. All right, be careful not to move it up or down at all. Finally, the last step is the midline is at -2. So we have to bring each point down by -2. This is at 0. I'm going to go down 1, 2. Whoops. And this point here, it's at 5. It's going to go down 1, 2. All right, so that should be it right there. All right, so hopefully that's correct. All right, fantastic.